Hello. So last time I explained how to install the nRF Connect SDK and compile the first Blinky example, which is already built in Zephyr, and how to flash it on a developer board. Today we want to program the GPIOs by ourselves. There are different ways. Sometimes, especially when you are using the first time the Zephyr function and the DeviceTree, it's a little bit overwhelming, so we will slowly dive into it. First, we create a new application. We are using again the Blinky example, and I call it just my second Blinky. Then here you're going on Add to Workspace, that you're getting the new application here. Yeah? And we have to create a new build configuration. I don't build it directly, it's taking so longer, I just generate the configuration. So when this is done, you can go on the source file, the main C file, and we just remove everything what's not interesting for us at the moment. Yeah. I just let the main inside, the while loop with the sleep, and this is all. The first reason why it's so comfortable to using something like Zephyr, in earlier time when we are programming something and we want to debug or print out something, of course, we had to complicate it, open the UART and sending them byte to byte over the UART, and now we can just use a function, for example, printk, which is quite similar to printf, so we can format it the same way and sending here hello world, for example. Yeah, and then I just build it and flash it to the board. So the board is already connected. Yeah, I'm using here the nRF Connect the nRF 52840 developer kit. We have it here. Yeah. It has the nRF 52840 chip. Here's a J-Link and a lot pins which we're having here, built-in LEDs, buttons, and we will send later programs the port 027 to let it blink an LED, so we put it to high and low in interval from 1 second. So, but the first thing what we have to do when the developer kit is connected, then we are just connecting to the COM port, and we're seeing our output here, hello world. Quite easy, we don't have to implement a lot, and helps us already for debugging. But we don't want to print out something at the moment, we want to control the LED. And there is a driver from Nordic itself, which is the HAL library. But when you're using this one, you can only use it for nRF kits or for Nordic kits. When there is another microcontroller, you would have to program it again new. But this is the way how we are used to control GPIO port. So first we set one pin to the output. I have to configure the GPIO pin also first. So I set here the macro, and I'm using port 027. Yeah, and here you see already a macro starting. Yeah, here's a macro, there's a macro, and here we are just setting this pin here as output. We can also see this pin when we're going on the device tree. Here there is a graphical overview, and we're seeing here our device, oops, it's a little bit small. Where is the pin 27? Is here as a downer pin. Yeah, it's also used for I2C, but we don't. It doesn't matter at the moment. So I set it as output, and in the next step, I just make it on and off. So here, GPIO, nRF GPIO pin set, and then I set it to high, and here I clear it and I set it to low again. Of course, I have to use here GPIO pin. Oops. And compile and flash it. And when we are finished and we're looking at our LED, which is connected on this port, we're seeing it's going on and off, and yeah, we can over this directly control the port. And we're having also built-in LEDs. So on port, we can check it on the DeviceTree, I think. On port, where's the LED? 14, for example, is the LED 1. So when I'm going back to our source code and I say just 14, build it. Flash it, and I go now to our developer kit here. You're seeing that's a LED 2. I mean, the numeration is here different here because in the DeviceTree LD 0 is the LD 1 here, and LD 1 is the LD 2 here. But even here we are using already a few macros, and like I said, it depends on the microcontroller. So when we are using this library, we cannot use another microcontroller. And still, with the function, we don't know what's really happening here. And what's happening is that we are always controlling registers. Yeah, so we're having here a 38-bit register, and there is a register where to store that one pin is an output, and then also one register where I set the output to high or to low. When we are looking in the datasheet, and I'm looking here for P0, then I'm finding the addresses from the register here. Yeah? I see here the register P0, and I'm seeing the output register with an offset from 504, and the direction register with 514. And this is, we will try this. So I'm using the base address here first. I make this away here, seeing the base address. Then we're needing the offset for the both registers, and then I need the bit position. So we are controlling bit 27, yeah. So this will here 27. And then we have first to set the port. I copy it directly. So we're needing a pointer to this register. So this is done through the base address added with the offset from the direction register. Yeah? So we have to call this a volatile pointer, because since we are not using this variable, the compiler would remove it for optimization if we don't make it volatile. Yeah? And then we're having here just a pointer to this register. And to set this register here, set it's an output, we're making the direction register and setting there a 1 to it. Yeah, we're making this with this shift operation. Of course, we can also set here directly the 32-bit here and setting bit 27 to this, but then we override the other one with the OR operation. The other register will stay the same. And here we are making the same with an output pointer, with a pointer to the output register, and afterwards we just have always to set or delete the register, the bit in the register, yeah? To set the right bit position here. So, and I build it, and now I can flash it. And then when I look again, yeah, the LED is blinking. So with all this function, we are just setting register, and on what way we are doing it, if we are using the nRF library or if we are using then the Zephyr function, it doesn't matter. Only how it's done, it's a little bit different. And in Zephyr, all the devices which are connected to our microcontroller and the resources are controlled over the DeviceTree. Yeah, you just saw it already when you're going here. We're having a graphical overview about the pin and the hardware which we control, which is active and so on. And when you're going here and open in text editor, you're seeing also the text file for it. Yeah? And it's really a tree, it's hierarchical done here. And what we are searching first is GPIO 0 here. Yeah? And when you're seeing here, when you're going, this is just an overlay file, yeah? From our developer kit. When I'm seeing the base file, you're seeing here from the microcontroller, you can click on it too. There's all already defined, and on the second file and so on, and they're then combined. Yeah. But when I go here on GPIO 0 and going over it, then I see also parameters which are set. Yeah. And for the first beginnings, the GPIO number here, which is the name, is important. And you're seeing here how it's built. It's from the root is SoC, and then the GPIO port with the number. Yeah, and we will use it like this. It's not the best way, but for the starting, it's more understandable. Yeah, so I'm just copy this here, place it here inside, and I remove all the base address here. And I have here 27, where the LED is on. And you're seeing, first I'm making such a, I need a structure, a device structure, and I get this with this function device get binding with the name which you saw before. And afterwards I'm just setting the pin configuration, that is an output again. I'm saying which device, it's the GPIO port 0 and the pin number 27. Yeah? And then I can set the pin to 1 or 0, this means to high and low. When I flash this to the board, you see again that the LED is blinking here. Yeah. Of course, to using here the name which is given here, it's also not so comfortable, because it can be from the device also different from the developer board what we are using. And when I'm looking at the GPIO port, we are seeing also that here is a label, so name GPIO 0. So it's better to going over this, and for this we're starting already to using macros. Yeah, I just copy it here, and you're seeing this label, they are organized internally with a string like this, which is called DT for DeviceTree node, and then the S is like a string sign, and then SOC, and then GPIO, and then the number. When we're going back here, this is actually the tree which we are seeing here. SOC, the slash, and then the number. But what we are needing for the binding is the name, and then I'm using another macro and just storing the name here. So in this macro will be later only the name. And with the preprocessor commands here, you have always to think it's really like a replacement. So when I set this here, the GPIO name, later, since the string which I'm just put there will be standing there. So it doesn't use any resources. So when we define a variable, we're needing always resources from the microcontroller. And when I do it on this way, it doesn't depend on the special number here. It just depends on the GPIO 0 if it's there or not in the device tree. And when I build it, and I flash this over again to the board, and I'm looking at our LED, and you see it's still blinking. And the device tree is even more, because we're having here, like you see, the LED 1 is already here at port 014. I can also look here, the LED, which is that's here, the LED 1. Here is standing the GPIO port, here is standing when it's active low, or when it's active. This is active when we're setting the pin actually to low and not too high, and also a label here. And it's better to using the command there, then every board which has an LED 1 will be then blinking the LED 1. And to doing this, I make the similar thing. I'm using again macros, and first I'm getting the LED node. I'm using now the internal LED, using LED 1. So the internal name will be the string like this here. Then I just changed it also. Then I'm getting the GPIO node label, which is the same label which I have here. So here is then standing actually this name inside, and you're seeing it's becoming already a little bit complicated when you're not getting used to it. And then again, then I'm putting here the LED 1 GPIO node, and I think I'm done, or did I forget something? No, the first thing, we can let it like this, flash it, and of course it's not working yet, because I'm still using the GPIO port here, the 27, and set it as output. This is not what we want actually. Here the variable is still written GPIO 0. We want to control now the internal LED. And for this I'm using another macros in this case, because I need the LED GPIO name I have already, but I'm needing the pin number, which is for this one 14, and the flag when it's high or not. And I get this through the macro DT GPIO pin, and then I'm getting the LED node, and here will be then standing 14 when we're looking at the LED. This is this one, GPIO, we're getting the 14, and here this will be the next one. We are getting the flag, not the pin, the flag, and the flag will be the active low, which is then short for 1. Yeah. And with this I can program the function on another way. First I set the right one as input and output. Then I'm using here the LED 1 node. Where I have it? Yeah, I'm using the same device, the GPIO device. I say it's an output, and the flag is from the LED 1 flag. So now I set this just as output pin, and I say when it's low and when it's high, that it's actually an active low. And the other, for setting the pins, I have also to replace. So I don't use this anymore. I'm using then the pin number, and yeah, also here I delete it again. Zero, and now it's independent from our specific microcontroller thing. It just depends on the device tree. Here I have an error, and just build it again. Flash it to our board. And you're seeing now the internal LED 2 is lightning, flashing. Of course, with so many macros here, it's overwhelming now, and it's really too much. It was just for understanding that you're seeing here also step for step. And we clean this now a little bit up because it's a better way to do this. Yeah, and we just need for this then one node. Yeah, so I really delete this all. I'm using then also LED 1. Yeah. Reading the LED 1 label here, and there is just stored this string inside here. I don't need the LED number or something, and I don't use the nRF hull function, so this is already cleaned up. And the second thing is I using a structure from the device tree. Yeah? So we don't use the device directly, we're using something which is then called GPIO DT spec, and there is the LED 1 specification. So in this container, in this structure is all then written what is in this device tree specification. You see this already what you're getting here back. You're getting the port numbers, the pin and the flag. It's stored there all inside. And to configure this as output, you're using a set, instead of GPIO pin configuration, just the GPIO pin configuration DT device tree gives the structure and sets this as output. And the last step is then setting the LED, and there's the same, the function is with the DT at the end. Here's the LED 1 spec, we're setting it to 1, and here to 0. Build it, flash it, and you're seeing that the LED is still blinking. Yeah? And I can always doing the same for our LED, for example. Yeah? You can add another LED here and setting the GPIO port, for example. We will do this later. You can make an overlay file, creating an overlay file where you can add components and configure. Say you're going in device tree and creating an overlay file, and then writing something like LED 4 and setting the same parameters there. We had really a lot macros in this video. I hope it was understandable. At the end we clean it a little bit up. You see, you can still manipulate the register directly if you want, or you can use the library from nRF like before. But how Zephyr doing is quite comfortable when you are getting used to it with the device tree. You can easily deactivate or activate something over the device tree file. And it's then also compatible to other microcontrollers or developer kits. You have not to adapt there much if the same resources is available there. I hope you like the video. Give it a thumbs up if so, and see you in the next video.